Alright, to see what's up with this, we're just going to take the regular determinant first of an n by n matrix. Here's a 3 by 3. And I wrote out all the cofactors and what the signs are just so it's convenient. So to take the cofactors along the top row to find the determinant, C11, C12, C13 going along here, which means I have to take this determinant, and this determinant. And I wrote those out here. First thing I'm going to do is take the regular determinant. So take these determinants, C11, C12, C13, and then I'm going to multiply them by the top row, A11, A12, A13, and then have the appropriate signs. So the top row times the cofactors that I chose, C11, C12, C13, should give me the determinant. A11 times this cofactor, negative A12 because the sign changes, times this, A13 times this, that's positive. And if we multiply all these out, we look here, we get all of those elementary products. That is the definition of the determinant. So looking at all these, each one of these comes from a different row or column. There are 3 positive, 3 negative. Those come from the permutations that we learned about when we first learned about determinants. And this is just equal to the determinant. So now let's see what happens when we multiply these cofactors by a different row, say row 3, so that way the signs don't change or anything like that. So instead of multiplying these things by A11, A12, and A13 from the top row, I'm going to multiply them by A31, A32, A33, and see what happens. So it's the exact same thing as this, multiplying by the different cofactors, except the third row. A31 multiplied by this, negative A32 multiplied by this, and then positive A33 multiplied by this. Multiply all this stuff out, and this is what you get. And what you're going to notice is that we're going to get things that cancel out. So A22, A31, A33, and then over here on the other end somewhere I've got minus A22, A31, A33. A22, A31, A33, this is positive. A22, A31, A33, and this is negative. So these are going to cancel out. And then you look over here, A23, A31, A32, and drew a line over here somewhere. A23, A31, A32. So those cancel, and then these cancel, so this is going to be equal to 0. And you can do this with any row or column. Anytime you multiply something against a set of cofactors in a row or column, so if I multiply the top row of cofactors by either the second or third rows, it's going to be 0, unless I multiply it by the first row, which will be the determinant. And the same thing goes for columns as well. If I took this column of cofactors and I multiplied it by this column of entries from the matrix A, I'm going to get the determinant. If I multiply it by this one, it's going to be 0. If I multiply it by this one, it's going to be 0.